Area of equilateral triangles is important because we're going to see it later in this course and you're going to see it later in mathematics. So it's important we spend a day on this topic. Below is an equilateral triangle. It's already labeled with sides of length S, S, and S. Write the degree measure in each angle. I'm going to draw an altitude from the top. When I draw this altitude from the top, it's going to affect that angle at the top. It's going to bisect it. Instead of having a 60 there, I'm going to mark this as 30, and this will be 30. So it bisected the angle at the top. It is also perpendicular to the bottom. So notice how we have two 30, 60, 90 triangles now. The altitude drawn to the base is also bisecting that base because this is an isosceles triangle as well, and the altitude to the base of an isosceles triangle bisects the base. While the whole base had length S, now each half of it would be S over 2, or half of S. We could label the base like that. What we're going to do now with this information is we're going to determine the height of the triangle. That's going to be a focus on the 30, 60, 90 triangle that we have. The 30, 60, 90 triangle has a side across from the 30-degree angle that is length S over 2. Do you remember that we take that shorter leg and we multiply it by the square root of 3 to get the longer leg? You see this height of the triangle is the longer leg of the 30, 60, 90. That's going to be S over 2 root 3. That's the height of the triangle. With that information, we're going to look at the formula for area of the triangle now. Area of the triangle formula we learned from the last section is 1/2 base times height. If I replace the base with the letter S, because that's how we labeled the base of that triangle, then I replace the height with our new expression, S over 2 root 3. This is the formula for area of an equilateral triangle. But you might be like, what? That's not easy to look at. So we could clean it up a little bit. Notice how there's a 1/2 in front. There's a 1/2 inside of it also. The 2 that's underneath the S, that's like a 1/2 times the S. So I can do 1/2 times 1/2, which is 1/4. So we'll have a 4 on the bottom. S times S is S squared. And I'll copy the root 3 there. I didn't do anything with it, but everybody was getting multiplied together. So this is a more condensed version of it. I like this one better. S squared over 4 root 3. Now all we are going to do is practice with it. Go to the next page. The quickest way to memorize that formula is to write it each time we do one of these problems. So let's write S squared over 4 root 3 for each of these problems, and that'll help us get it memorized. The side of the first triangle is 7, so I'm going to substitute 7 in for S, and then I'll simplify whatever I can. There's not much to do here. 7 squared is 49, and that does not reduce with 4, so we are done with 49/4 root 3. Number 2, let's write the formula again. S squared over 4 root 3. Substitute in 4 for S. This one will simplify. I can cancel the 4 on the bottom with a 4 on the top, and I'm left with 4 root 3. The area of this triangle is 4 root 3, and I have to put meters squared. And I didn't put the unit on the first one, so I'm going to do that also. So the first one was centimeters squared. I'm going to ask you to look at 3, 4, and 5 on your own, pause the video, and then come back to check your answers. Okay, we're going to check our answers. I hope that you wrote the formula for each problem. So S squared over 4 root 3. Remember, we're trying to memorize that formula. Put 1.4 in place of S, and that turns out to be 0.49 root 3. I actually prefer that you write 0.49 root 3 as 49/100th root 3, and the units are kilometers, so I'm going to write kilometers squared. So you could write it that way. If you wrote it this way, I would not mark you wrong. That's okay. Number 4, I don't actually have the whole side given to me. I only have half of a side down here, but this is an equilateral triangle, so I know the other half is also 4. So the whole length of the side here is 8, and I can just go ahead with my formula now. Area equals side squared over 4 root 3. Substitute in 8 for s, and that does reduce with 4. So 64 divided by 4 is 16, and we had units of inches, so our answer will be in inches squared. Now in number 5, I don't have the side at all, but I have the height. Do you remember that this is a 30, 60, 90 triangle on this side? The 6 root 3 is on the longer leg. That means the shorter leg is just 6, because you divide by root 3 to get the shorter leg. And if that much of the bottom is 6, the other half of it is 6. So the whole side of the triangle here is 12. Write your formula, side squared over 4 root 3. Hopefully you get it memorized. Replace s with 12. And 12 squared does reduce with 4 to 36. And let's put feet squared there for the unit. I hope you did well on those 3. Number 6. We're being given the area of the equilateral triangle. So let's write our formula down. Side squared over 4 root 3. This area number is going to take the place of a this time. So 16 root 3 equals s squared over 4 root 3. And the fun part is I can divide both sides by root 3. So 16 equals side squared over 4. Multiply both sides by 4. 64 equals s squared. Take the square root of both sides, and the length of the side is 8. That is not what I was being asked for. I was being asked for the height, so I'm not quite done yet. Remember, the height bisects the base, and if the whole side is 8, then half of it is 4. And that's the short leg of the 30, 60, 90 triangle. The longer leg is going to be 4 root 3. Height is 4 root 3, and the unit is centimeters. The last page has 3 practice problems for a closure. So it's like we wanted you to do just 3 more practice problems. Please pause the video and do these 3 problems and turn the video back on to check your answers. Now let's get the answers for the closure. Did you write the formula for each problem? Side squared over 4 root 3. Number 1, replace s with 6. 6 squared is 36. Divided by 4 is 9. Number 2, write the formula again. Replace s with 8 root 3. You can use a graphing calculator to calculate 8 root 3 squared. I won't do that. I'll do it in my head. 8 root 3 squared, I would do 8 times 8, which is 64. So I'm going to leave that down there, 64. And then root 3 times root 3 is just 3. So that'll be 64 times 3 when I am done. 4 does cancel with 64, and that leaves 16 behind. And 16 times 3 is 48. So the area of that triangle is 48 root 3. The third problem, we're actually given the height of the triangle to this base. So it's like the right side is considered the base in this situation. And you know the height of the triangle is like the longer leg of a 30, 60, 90. I'm going to have to divide by root 3 to get the shorter leg. So 6 divided by root 3, rationalizing the denominator, I'm going to get 2 root 3 for that short leg. And that short leg only is half of the base up to here. So the other half is 2 root 3. That means the whole side of the equilateral triangle is 4 root 3. Write your formula. Substitute 4 root 3 for s. The 4 gets squared, which is 16. Root 3 gets squared, which is 3. The 4 does cancel with the 16 and leaves a 4 behind. 4 times 3 is 12. So the area of this triangle is 12 root 3.